Welcome to Catalyst Grid. My name is Kingsley Amufua, lead scheduler with DC Nordics. Today we examine Building the Machine, Series 2, Hyperscale, Episode 18, Commissioning FULCRUM, Campus IST at 85 megawatts. In Series 1, Episode 17, we walked through the Iron Gate commissioning program. The 5-tag framework remains the gold standard. Red tag, FAT, and documentation. This stage ensures that every piece of primary equipment meets the design specifications before arriving on site. Yellow tag, QA/QC inspection. This is the rigorous validation of physical installation, checking every connection and component against the BIM. Green tag, energization, the critical point where the system first receives utility power, transitioning from a construction site to a live facility. Blue tag, functional performance testing and the heat load test. We verify that every component functions exactly as intended under stress. White tag, the final integrated systems test. This is where we prove the resilience of the entire campus as a single unified machine. The difference between Iron Gate and FULCRUM is pure scale. At Iron Gate, the ICA team was just 4 people. At FULCRUM, it is 14. The ICA lead on FULCRUM reports directly to CloudCore. They are independent of the SPV and the EPC contractor, ensuring unbiased validation. 4 hall commissioning managers each own the full 5-tag program for their assigned hall, from red tag FATs through to white tag IST. Discipline leads manage their specific systems across all 4 halls. This structure ensures consistency and enables rapid cross-hall learning. Level 1, red tag at FULCRUM takes 8 weeks. We are managing over 100 OFCI packages compared to just 43 at Iron Gate. This includes 20 generator FATs. Each one requires a 2-hour full load test, with the LTA required to witness every primary equipment test. Level 2, yellow tag is where the scale of FULCRUM truly hits. We have 4 times the punch list items of Iron Gate, requiring massive coordination. DCIM sensor verification is a massive addition. All 50,000 monitoring points must be verified against the as-installed BIM model. Level 3A pre-startup covers insulation resistance testing at 132 kilovolt levels, a significant leap from the 11 kilovolt distribution at Iron Gate. We also added seismic restraint verification for all MEP services, a new requirement for FULCRUM to meet stringent hyperscale resilience standards. Level 3B green tag is the single most significant commissioning event, the 132 kilovolt bulk supply point energization. The BSP is owned and operated by the transmission system operator. Our team attends as witnesses, but the TSO switching team is in control. The sequence is formal. The TSO coordinator issues a switching program. Each action is read back by the operator before execution. The ICA lead records each action against the agreed program. Any deviation requires the coordinator to assess and either resume or stand down. Energization was conducted on a Sunday at 5 a.m. This ensures lowest grid loading and minimal risk to other network customers. The BSP energization took 2 hours and 40 minutes. By 6:15, the 33 kilovolt output to the on-site compound was confirmed stable. The green tag was applied to the 132 kilovolt switchgear at 7 a.m., witnessed by the TSO, the ICA lead, and the LTA. Level 4, blue tag. Functional performance testing is conducted in 2 stages, per hall testing followed by campus-wide combined testing. Each hall is tested independently at 4 load steps, verifying the cooling system, power distribution, and monitoring systems at every stage. Data Hall 1 testing runs first for 4 weeks. The load bank fleet is then transported across the campus to follow the same schedule for Hall 2. The campus-wide combined blue tag loads all 4 halls simultaneously. This tests the shared infrastructure under full campus demand. We are testing the BSP loading, the on-site substation, and the waste heat recovery system under maximum heat rejection. At 100% load across all 4 halls, we reach 85 megawatts. This is the ultimate test of the shared high-voltage infrastructure. The blue tag OAT result was exceptional, a campus PUE of 1.19 with cold aisle temperatures across all halls within ASHRAE specifications. Level 5, white tag integrated systems test is the most complex commissioning event ever conducted by this team. Over 6 weeks, we execute 31 test scenarios. These range from single hall events to campus scale failures with no single building equivalent. Scenario 1, total BSP loss. We trip both incoming feeds. All 20 generators must start within 10 seconds to restore campus power. All 4 hall UPS systems must support the IT load from battery through the transfer. We verified 0 IT load interruption across the campus. Scenario 2, single generator group failure. Trip all 5 generators in Hall 1. The load must transfer to Hall 2 via the bus coupler within 30 seconds. Scenario 3. Campus cooling failure. Trip the primary chiller. We verify standby chiller activation and temperature stability across all 4 halls. Scenario 4. DH1 EPO. Cloud core places a controlled shutdown. We activate the EPO and verify that halls 2, 3, and 4 are completely unaffected. Scenario 5. VESDA pre-alarm. Trigger in DH2. Verify the alarm routes to the campus SOC and does not propagate to local panels in other halls. Scenario 6. Campus power quality event. Inject a 3-second voltage sag. We verify that all UPS systems ride through without transferring to battery. The campus-wide white tag was issued for Hall 1 at the end of week 6. This was month 35, 1 full month ahead of the contracted date. Unique to the DBFO structure, the LTA must countersign the white tag before Cloud Core's IT Ready certificate can be formally issued. The IT Ready certificate followed within 48 hours. Project FULCRUM had officially transitioned into its operational life. Time for the series signal. At campus scale, resilience isn't just about individual hall redundancy. It's about the shared infrastructure. You must plan cross-hall scenarios that test the dependencies between buildings. A single hall program cannot validate campus-level resilience. Plan the campus IST from month 1 of the program. Designing these scenarios early ensures the infrastructure is built to support them. Episode 19 is our series finale. Practical completion, the operations handover, and the lessons from 42 months of building FULCRUM. Make sure to subscribe, like, share, and comment. Your support keeps the Catalyst grid running. This is Kingsley Amufua. One love, brothers. Stephen, signing off.